All right, now we've done everything we need to do to run the model. Though I'll show you in a minute a couple of other adjustments that I prefer to do. So in order to run the model, you can either go to the Analyze menu and click Calculate Estimates, or use the keyboard shortcut Control F9. Or you can come down here on the left and go to this abacus and click Calculate Estimates. Once you click Calculate Estimates, AMOS will go through the statistical things it needs to and will provide you the estimate. You can see down here, it gives you, here on the left, it gives you a little bit of detail about the model. It also tells you that the model was okay, and what that means is just that it estimated okay. We can then click on this button here, and what this does is it'll now show our parameter estimates. Okay, these ones up here are our factor loadings, we have our error variances, and then this 0.58 is the variance for the latent variable. As I'd said earlier, when you use AMOS's latent variable tool, it'll set one of these factor loadings to 1 for identification purposes or model identification purposes, as we discussed in class. But as we also discussed in class, the other option is to set the variance of the latent variable to 1. And I often like to do that, and so I'll show you how you go about doing that. The other thing I like to do is label all of the relevant parameters in the model. This is useful just to keep track of them, as well as it's useful later on in analyses when you need to impose constraints across models to have a label for each of the parameters. So that's what we need to do first, or what we're going to do first, is label each of the parameters. And we're going to do it in the same way we labeled or gave names to each of the latent variables. And we do that by right-clicking on factor loading. And we'll again get the Object Properties menu. So click on Object Properties and go to Parameters. And you'll see down on the left there is a box called Regression Weight. And that is the factor loading. And given that we clicked on that first factor loading, it's saying that regression weight is equal to 1. But we're going to give it a variable name. We'll call it B1. So AMOS is just going to recognize that as a variable name and not a number. So let's label each of our regression weights. There are 5 of them, so we'll do B1, 2, 3, 4, and 5. Might have been better to label them B2, 3, 4, 5, and 6, since that's closer to, or would be consistent with the names of the items. So you could certainly go ahead and do that if you'd like. We'll also label the error variances. So we'll call the first error variance E1, second E2, 3, 4, and 5. Okay, and so remember we're going to estimate error variances, and we need a name for those. Lastly, we're going to label the variance for the latent variable. So we'll call that var1 for variance 1. Okay, so now we've labeled everything. Close that up, and then we're going to go to the Tools menu, or excuse me, the Analyze menu. And we're going to go to what's called the Manage Models box. So click on Manage Models, and this box comes up. What you have is, over on the left, it gives you all the parameters you've labeled. And what you can do in here is provide constraints, or you can set certain values for each of the parameters that you're estimating. So what we want to do is give the variance for the latent variable, which we've defined or called var1, we want to give that a value of 1. So we go down into the parameter constraints area, we type var1 equals 1. Okay, And so that will set the variance of the analysis, or excuse me, of the latent variable in the analysis to 1. And this will allow us to estimate all the factor loadings separately. You can give a name to the model. The default model is usually fine, but later on we'll be changing that name so that we can keep track of which model we've run and which model has which constraints and that sort of thing. So I'll just call this demo. So once you're done with that, you just click close, and now we've imposed that constraint. So we again hit calculate estimates, run through. We can see that the demo model has an OK next to it, so it's estimated OK. We can again look at the unstandardized estimates. We'll see that we have all these factor loadings. The variance of the alliance is set to 1. And then we have our error variances listed up here. All right, last, sometimes you want standardized estimates and a couple of other pieces of information. So we'll go to the diagram, or excuse me, the view menu, and go to analysis properties. The default window that comes up when you do analysis properties lets you choose different ways to estimate the model. The default is maximum likelihood, and that's what we'll be using in this class. It's also got some other options that we're not going to use right now, that we may use them later on in the semester. But let's go to the output option, or excuse me, tab. And under that, these are things you can get, have AMOS output for you, so you can have that information after your model has been estimated. There's lots of options. We'll use some of them during the class, and others we won't get to. By default, it provides the minimization history, which is information about the estimation procedures. But the two that I want to click now, and that I typically click each time, would be the standardized estimates and the squared multiple correlation. So the standardized estimates will give us standardized factor loadings. The squared multiple correlations will give us the R-squared values for the items. So basically, it'll tell us how much variance in the item is accounted for by the factor. So click on those two things. And then to get them, all you have to do is click calculate estimates again. It'll output that information. Now we can click on view, this different views, so we can see the estimates. So these again are our unstandardized estimates. If we want the standardized ones, now we just click on standardize here. And what it does is it'll get rid of the variances, because the variances in the standardized estimates are all 1, so they're a constant, so they don't get displayed. Same with the alliance one. And then it gives the standardized estimates of the regression coefficients, or the factor loadings. And then these right here are the R-squareds. So we can see that 61% of the variance in item 2 is accounted for by the latent variable that we're calling alliance. A little less in item 3, a little more in item 4, a little less in item 5, a little more in item 6. So you can see also that not surprisingly, the R-squared is a function of the factor loadings here. The bigger the factor loading, the bigger the R-squared.